This is let us see, and we are looking at chapter number 10, structures. So many a times when we are dealing with say an individual item or group of item of same data type, then we can have this integer, float and character or an array. But we would require in our practical application sometime that this integer, float and character, all data type should be there. So why use structure and what are structures? Ordinary variables can hold only one piece of information, and if you talk about arrays, they can store number of pieces of information of same data type. But when you want different data type to be kept, that is dissimilar data type we want to keep, for that we would require structures. Suppose we have a book and we have to put or store the name, the price and the pages. So we have say 3 such books. For these 3 such books, we have 2 approaches. First, we can construct the individual arrays, maybe one for storing names, for storing prices and for storing number of pages. And the second option is to use a structure variable. So let us see these approaches one by one. This is the first approach using the arrays. So we have 3 arrays, 1, 2, 3, and this is for name, this is for price and this is for pages. We have entered for 3 books, and because we are entering from these are 3 books, so 0 to 2, we are saying ampersand name, ampersand price, ampersand pages with the subscript. Now these will be entered and you can just show it. Again, the same thing with printf. So this is how the sample run of the program would look like. You enter these entries for 3 books and this will be shown. But this is very good, no doubt about it. But just realize that you are not dealing with group. You are obscurely or you are dealing with individual identity or individual entity. A book, like a book, this book should have its name, the pages, the author, everything, publisher. This one, once we deal with this B1 or book, it should give you all these content. So this programs become very difficult to handle as the books, they goes on increasing. Somebody comes to you, he wants publisher, purchase of book, all these information he wants. So C provides a special data type for that, and this is a structure. Please understand that this is a structure, is a special data type. So a structure, this contains a number of data types together, or you can say dissimilar data type together, and these data types, they may be or may not be of same type. Let us see the book example with the structure. So we have a struct here. This tells the compiler that this is a structure. Then we have the name of the structure, and then we have these entities, and here we have structure variables B1, B2, B3. So how to get hold of the name from B1? B1 dot name. See, B1 dot name, B1 dot name, ampersand because we are scanning the name, B1 dot price, B1 dot price. So dot operator we are using. For scanning we use ampersand, for printing we use just this one, right? So we are making a structure, then structure variable, these are structure variables, and we are attempting with the dot operator to get hold of these. And now we can store also, we can print also. So this is the sample run and the result will be same. So this program is demonstrating us the fundamental aspect of structure, that is declaration of a structure and accessing the structure element. So let us see how to declare a structure. So this is how we declare a structure. This is the statement showing the structure type. So we have a struct here, and this is the name of the structure. Then we have 3 entities here. You can give any entities, you can give the pointers, you can give the arrays, and then you end it with a semicolon. Please understand, you end with a semicolon. Then this statement defines struct book. We have name, price and pages. These are dissimilar entities. So if you want to generalize it, then struct, then structure name, struct and structure name. These are different elements and followed by the semicolon. And we see that once we have declared a structure, this structure book B1, B2, B3, these are 3 variables, and this statement will set aside space in the memory. So it makes the availability to hold the item. So say we have name, price and pages. So how much or how long the size will be. See, the name is a character we have taken, so it will take 1 byte. Then price will, because it is a float, so it will take 4 byte. Then we have pages, it is an integer, then 2 bytes. So 4 plus 2 plus 1, that is 7 byte it is going to take. For this one, 7 to the 14 and 7 3 is 21. Now we can do these activities. Means struct book, this you have already seen. We have given the various entities here, and we have made a different, outside the structure we have declared the variable. Now you can declare the variable inside the structure by itself. Means before the semicolon you can do it, and even this is possible. If you don't give the name, it is also possible. And please understand, because this type of questions are asked normally. The way the primary variables arrays, all these are dealt, because we said structure variables are variables only. So the format is quite similar to how we initiate the arrays or initialize the array. This is a structure. We have name, we have price, and we have pages. How to initialize? We have said struct book, this is B1, struct book B2, and we have initialized the name as basic, here price as the 130.00, pages as 550, and likewise for the B2 also. And we have to note here that the closing brace in the structure type declaration must be semicolon. After that, it must be a semicolon. And the structure type declaration does not tell the compiler to reserve any space until unless you make the variable. Usually this structure type is given at the top before any variable can be defined. And if we have a large program, we have various structure, then we define that those structures in the header file, and we use that header file using the hash include. We can include it in our program. How to access the structure element? Once we have declared the structure type and structure variable, we need to understand that we use this dot operator. If you are using directly dot operator, if you are using the pointer variable, then we use this operator. So this, if we have a book, say B1, and if you want to find the pages, B1 dot pages, B1 dot price, like this. So this dot operator becomes very important. This in this dot operator, the left side and right side are important. So before the dot operator, it must always be a structure variable, and after the dot operator, it must always be a structure element. So how structure elements are stored? They are stored contiguous memory. The way arrays are stored, they are stored in contiguous memory. So we have main here. This is structure, book, name, price and pages. We have initialized it now. And when you want to print name, price and page, you see that if some address is there, the next one will be +1 and the next one will be +4 because of this. So this is +1 and +4. B1 dot name you can access B1 dot price you can access price, and B1 dot pages you can access the pages. Now this is the character, so it takes 1 byte. So we have 65518, it takes 1 byte, so it will go up to 65519. The next address will start at 65519. Now this is float, so it will take 4 bytes. So 4 byte means 19 to 23. So it will take 4 bytes, and this, because this is the B1 dot pages, so it is going to take, because this is an integer, it is going to take 2 bytes. Array of structure. Array of structure, because array are variable only, so we can always have array of structure as we have array of variable. Why would we require it? See, if we have 10 elements, it's okay. We can make 10 structure variable. But if 100 books are there, 1000 books are there, we cannot make B1 to B100 these number of structure variable. It will be very inconvenient for us. So the best idea is to use the array of structures. Let us see this program. This is using the array of structure. So inside main we have created a struct. This is name, price and pages, and then we have a struct which is the type, but we have defined, or you can say declare, an array of 100 size. This is an array. Now from 0 to 99, because this is what the first one will be B0, the first book, second will be B1, and likewise till B99. So now here we can enter the different values for each and every book, say name, price and pages. And now how to access this? The same way we access the array. So we have a subscript here. BI means B1 dot name, B1 dot pages, B1 dot price, like this. So this is how we print also. So in this program we have to see that array of structure is declared like this, struct book B100. So it gives you the space for 100 structure, and the syntax we use to reference each element of B is similarly the way we treat integer and character arrays. For example, the 0th book will be, the price of 0th book will be B0 price, and the first book page number will be B1 dot pages. And this is very good because Dennis Ritchie has really given us this array of structure which makes our life quite easier. And the storage where these array of structures are stored, array of structure are stored, all elements of array, they are stored in adjacent memory location. Where? Adjacent memory location. So first B0 content will be there, 3 content, then B1. So this is name, price, page for B0, name, price, page for B1, like this. There are some other feature for structures. The value of a structure variable can be assigned to another structure variable without any problem. You can easily use equal to sign, or you can assign piecewise, one by one. So we have a structure employee, we have name, age and salary, and then we have struct employee E1. So we have initialized it with the name and other content. Now we have again initialized or declared E2 and E3. This is initialization. We have declared E2 and E3. Now the piecewise copying will be E1 name to E2 dot name, because E2 is empty, E1 dot age to E2 dot age, and E1 dot salary to E2 dot salary. But if you want to copy directly, you can use the assignment operator. So E3 is now the next one. So E2 we have initialized with the value of E1. Now E2 can be initialized directly to E3. So this is also possible. And this is how we can directly copy, equating, just equating can be done. And the nesting of structure is also possible, and we have to use multiple dot operator for that. For example, in this program we have a structure address. This is phone, city and pin. Now we have another structure in which we have a name, and inside this we have structure variable which is pointing to this one, which is actually this structure. So if we initialize this E, if you are initializing this E, we have the content like the name. First name will come, then phone, city, pin, phone, city, pin. This is phone, city, pin. So this is you can easily print, but E dot name and E dot A dot phone, because if you want to access the name, because you are making a variable of EMP, so EMP, inside EMP you have name, so E dot name is okay. But when you are accessing phone or city or pin, then first you have to take A, means E, then E dot A, inside this E dot A you have phone, so E dot city, E dot A dot pin, likewise. This is the output. So this you have to understand. Then if you have a nested, then you have to go to multiple dot. And just like an ordinary variable, a structure variable can also be passed to a function. It can be passed one means piecewise, or you can directly pass whole structure. Let us see the approaches now. You are passing individual structure element. This is a structure called book. We have 3 contents here. Now we have initialized this structure, and we are passing piecewise B1 dot name, this one, B1 dot author and B1 dot call number. So here we see that we are just because these are strings, so we are taking it as these two, and this is the end, which is our call number. and we are just printing it. And now we see here the b1 dot name we have taken as star s, this is taken as star t, and this is taken as n. So these two are called by reference because we are passing the address, and this is called by value. So this is a mixed call by reference and call by value, both are there. Okay. Now let us see a program here. This program is saying what? This program is saying that we can pass whole structure at one point. We can pass the structure like this. We have a structure here, book, which is B1, and now we are passing this B1. And when we are passing B1, we are taken struct book B, because this is a structure, we are taking it in the same structure variable. And we are just using this B dot name, B dot author, and B dot call number to print it. So the same result will be there. So this is how we call, and when we call this B1, we have initialized B1, and this struct book is not known to display. So just see this program once again. In this program, this struct book is declared outside the main because we have two functions, main function and display function. If you declare this struct book inside this main, this will be only known to this main function. This will not be known to display. For that we have taken it out, and mostly these structures are always given on the top of means above main. This you have to understand very carefully. And the way we can have a pointer pointing to an integer or a pointer pointing to a char, we can have pointer pointing to a structure also. This is called as structure pointers. We have a program here, we have a structure, all the contents. Now we have initialized this B1. We have initialized B1, these are content. Now here we have also a pointer or structure pointer. Now we have given the address of B1 to PTR, and this B1 dot name, B1 dot author, B1 dot call number, from B1 if you want to access, you use the dot operator. But when you are using the pointer, we use the arrow operator. This is very important. So I hope you got the idea. Dot is used when you are using normally. When you are using pointer, you have to use array. So this thing lies here is B1 dot name, B1 dot author will contain the content like this. This is the address, and this PTR is actually having the address of this one. And can we not pass the address of a structure variable to a function? Yes, we can pass this. Let us see an example. This is a structure. Now we are declaring or say initializing B1, and now we are passing the ampersand, that is the address of B1. This is the address, and this, when we are passing the address, it has to be the pointer B, and when you are using pointer, you have to access it through arrow, and this is the output. So please understand, this arrow has to be used when you are using with the dealing with the pointer. And just take one more example here. We have a structure, these are the content, and now we have structure employee E. Now E dot A, E dot C, E dot S, this is %u. So it is going to give you the address. But in TC++, it will be fine. This will take 2, this will take 1, this will take S. But as expected, the character begins immediately after integer and float begins immediately after the character. But when you run it in this VC++, you will find that it will be 44, 48 and 52. So you see that there is a gap. There is a gap between the addresses. Why? Because C or Turbo C, C++ compiler, it uses 16-bit. VC++ is the code is meant for 32-bit processor, and because of this there are gaps because it is dealing with 32 bits. For that we have pragma pack. How to use this pragma pack? You can pack those holes can be packed. For that you can use hash pragma pack, and this we have structure emp. Now you have used this pragma pack, and this, when you print these three, you will have a proper values which are expected. So there are various uses of structure. Basically it's you can say a short way to represent the database, and these are all the possibilities which you can use with structures. These are just few, and it depends totally upon your work application, in which way you want to use the structure. So let us summarize. A structure is used when you store dissimilar data together. The structure element are accessed through dot operator, structure variable and dot operator. The structure element can be accessed through a pointer to a structure using the arrow operator. And all elements of one structure variable can be easily assigned to other using the assignment operator. And it is possible to pass the structure variable to a function either by a value or a address. And it is possible to create array of structures also. So thank you so much. This was all about the structures. Take care of yourself.